Right, so we're going to look at parallel lines now. Parallel lines, by definition, never intersect. So that's a very key feature here, is that they never intersect. But they also exist on the same plane. You could have, even in 3 dimensions, if these markers represent parts of a line, you could have lines that never intersect that kind of just go like this. They're not really in the same direction, they just miss each other. Those aren't parallel. You have to be in the same plane like this. Whiteboard is a plane. You know, you have lots of different lines, they intersect, but if they don't intersect, they have to be actually going the same direction, then we call them parallel. So they have to be in the same direction, they have to be never intersecting, existing in the same plane, therefore they're going in the same direction. Okay. Same direction, different location. Apologize for my handwriting here. What is that? That's terrible. E-R-E-N-T. There we go. So yeah. Anyway, those are some features of parallel lines. So if I were to sketch real quick a set of parallel lines, and of course they're not going to be perfectly parallel. In fact, they're not even perfectly linear. Oops. We often represent parallel lines by using a little arrow on each one. You don't have to. Sometimes we'll just designate them as parallel. We'll say parallel lines. I like to use a little arrow notation, but sometimes we do other things. Just describe it in the instructions or something. But let's say you had 2 parallel lines. They never intersect, so there's no angles there to deal with, right? I can't get vertical angles or anything weird like that because there's nothing there. There's no intersection. But if I were to run a 3rd line through them and intersect them, that 3rd line is what we call a transversal. Okay, so yeah, so this is a transversal. I'll even define them over here. A transversal intersects 2 parallel lines, so it's a line that intersects 2 parallel lines. Now, what's neat about that is that we actually can get, you know, it forms 8 different angles, and we can get some cool relationships, really useful ones, between those angles. So if I were to label these like angle 1, 2, 3, 4, 5, 6, 7, and 8, and then, you know, your book might even label them differently, and who knows, but I'm just labeling them that way. If I were to do that, then I can, based upon what we've already been seeing with supplementary angles and with vertical angles, we can get interesting pairs up here, right, comparisons. One thing we know is that angles 1 and 2 are supplementary, 1 and 3 are supplementary, 3 and 4, 2 and 4, all those pairs are supplementary, and the same goes down here. We also know that 1 and 4 are congruent, 2 and 3 are congruent, 6 and 7 are congruent, 5 and 8 are congruent because they're vertical angles. What's also very interesting is that the angle formed, let's say right here, angle 2, this angle that's formed by the transversal with the first line is equal to the angle formed here at 6 with the transversal in the second line. The angle doesn't change, okay? Because the parallel lines run in the same direction, this cuts them both in the same way, in the same direction. And so that angle is the same, and really all the corresponding angles are going to be the same. So we would say that corresponding angles are congruent. Okay, and so based upon that, I can get some really important relationships. I know that angle 1 is congruent to angle 5. Angle 1 congruent to angle 5. I know that angles 2 and 6 are congruent. know that 3 and 7 and 4 and 8, those pairs. Oh, 3 and, what did I say, 3 and 7? And 4 with 8. Doing that fast, I'm missing a little bit of detail. I think I got it right. Okay, so those 4 relationships are a result of the corresponding angles, okay? So 2, 6, 4, 8, 1, 5, 3, and 7, those pairs are all corresponding angles. They're in the same position with respect to the transversal on each parallel line. We also have a definition. We're going to call, let me get rid of my description here for parallel lines. I'm going to say these are alternate interior and alternate exterior angles. Alternate interior angles are congruent, meaning their measures are the same. And the alternate interior angles, if you think about the inside, we're looking at the inside in between the parallel lines. And alternate means they're on different sides of the transversal. Okay, so alternate means, I'll use a different color to define this. Alternate means different, E-N-T, different sides of transversal. Interior means between parallel lines. Okay, so in between the parallel lines on opposite sides of the transversal. So in that case, we're really looking at angles 3 and 6. So angle 3 is congruent to angle 6, and 4 and 5. So angle 4 is congruent with angle 5, okay? Now likewise, alternate exterior angles are congruent. Exterior means they're on the outside of the parallel lines. So alternate exterior angles are congruent. And those pairs are going to be 1 and 8 because they're on the outside and they're on opposite sides of the transversal. So angle 1 congruent with angle 8, and let's see, 1 with 8, 2 and 7. So angle 2 is congruent to angle 7. Right? So those combinations are also true. So we've got lots of congruencies in this diagram. We also have lots of supplementary angles, right? Pretty much anything that's not equal to each other is supplementary. Or I should say anything that's not congruent will be supplementary, okay? Cool. Okay, and of course the vertical angles we said already are congruent as well. Now, let's take all this information and we'll run through a couple of quick examples here. In fact, I'll do that in the next video.